Okay, this is the fall final review, starting with question number 28. So the directions here say that I need to solve the absolute value inequalities. So the first thing I always want to do is make sure that the absolute value is isolated. So on question number 28, it is already isolated, so there's no numbers outside of the absolute value. So then I want to split it into two equations. So I have 3x minus 10 is less than or equal to 2, and negative 3x minus 10 less than or equal to 2. So whenever it's a less than, we use and, right? So one of the things we thought about was less than, so that's why it's an and statement. So then I want to isolate the x on each of these equations. So the first thing I want to do is add the 10 over to the other side. And then divide by 3. So x is less than or equal to 4. And then I want to do the same thing on this side here. So I can either distribute the negative or divide by -1. Either way, it doesn't matter which way I do that. So I'm going to go ahead and divide by -1. And whenever I multiply or divide by a negative, I need to reverse the inequality. So instead of less than, I'm going to switch it to greater than. And then 2 divided by -1 is -2. And then isolate the variable. So I'm going to add 10 to both sides of the inequality. And then -2 plus 10 is 8. And then divide by 3. So x is less than or equal to 4, and x is greater than or equal to 8/3. So it also says to graph it, so I'm going to go ahead and do that. So because it has the equals piece, I'm going to use a closed dot on the 8/3 and the 4. So x has to be less than or equal to 4, so that's going this direction, but also greater than or equal to 8/3, so that direction. So then it's going to be shaded in between, so it's a conjunction. And then to put this in interval notation, I want to do left comma right. So 8/3 comma 4, and then brackets because of the closed dot. And then let's take a look at question number 29. So I need to isolate the absolute value first. I'm going to divide both sides by -2. I divided by a negative, so I want to switch the inequality. So it'll be greater than, and then -10 divided by -2 is +5. So as soon as the absolute value is isolated, I want to split it up into two equations. So I have the positive version, x plus 1 greater than 5, and then it's greater, so or. And then the negative version. So I have the positive and the negative. And then solve each of these. So I'm going to subtract 1. So x is greater than 4. Or. And then again, I could either distribute the negative or divide by -1. Either way, I'll still get the same answer. So I'm going to distribute this time. And then solve for x. And divide both sides by -1. So I'm dividing by a negative, so I want to reverse the inequality. And 6 divided by -1 is -6. So x is greater than 4, and then or, just kind of do that, kind of weird, or x is less than -6. So then when I go to graph this, so -6 is smaller than 4, so -6 is on the left. And then I do not have an equals bar underneath, so that means these are both going to be open circles. So here x is greater than 4, so I need to shade to the right. And then x is less than -6, so I'm going to shade to the left. So I have two different intervals shaded, so that means I need to have two different intervals. So I'm going to do this side first. So I'm going to do left comma right. So left, this is an arrow, so that would be -infinity. To the right is -6. Parentheses on both because it can't equal infinity and it's an open dot. And then union. Now I want to do this part of the graph. So left comma right. So left is 4. And then it goes forever to the right, so +infinity. Okay, and then let's take a look at question number 30 here. So I want to isolate the absolute value. So a lot of times I see students try to add 2 and 2 together, but 2 is multiplying the absolute value, not being added to 2. So by order of operations, I actually need to subtract 2 from both sides first. And then divide by 2. Okay, and then so now I have a negative. Whenever I have a negative with absolute value, I need to stop and think, right? Not keep solving, but stop and think about what's happening. So I have this absolute value greater than a negative number. And I know absolute values represent positive numbers. So what I want to ask myself is, what positive numbers out there are greater than -1? All of them or none of them? And I know all positive numbers are greater than -1, so then x can be any real number, right? So that would be all reals. So all real numbers, or another way to write that is from -infinity to +infinity. So then this would be all reals. So if this had been reversed, like a less than, there is no positive number smaller than a negative, so then it would have been no solution, okay? Okay, so for question 31, this is when we're analyzing our graph. So let's go ahead and take a look at this one here. So for question number 31, it's wanting us to list all of the labeled points that are solutions for g of x equal to 0. So g of x equaling 0 is when my y is 0, and my y is 0 when I am on the x-axis. So that's really asking for what are my x-intercepts, right? So when it says g of x equal to 0, that's y equal to 0, which means we are on the x-axis, so I'm looking for my x-intercepts. So if I go to the g of x graph, let me zoom out one here. That's the curve, so g of x is this one right here. And so where is that crossing the x-axis? And that's at this point here, which is C. Here it's asking for us to list all the labeled points where g of x is equal to f of x, and that's where they cross each other, or the intersections. So where do g and f intersect? So they intersect here at B and here at E. So they touch each other at points B and E. So for part C, it's asking us to list all of the labeled points that are solutions for y equals f of x. So that just means all of the points on f, right? So all points on f of x, so here's f of x, so point A, point B, and point E. Okay, so for part D, it says to list all of the labeled points on f of x that are solutions for g of x less than f of x. So this is kind of confusing because they're asking us about f of x, but then they have the inequality switch. So I'm just going to turn that around. So I'm going to rewrite this. So I want to know, where is f of x greater than g of x? So where is f of x greater than g of x? So I'm going to just go point to point. So right here, A is point A above G, and it is. Is point B above G? No, because it's actually on both, right? That's an intersection point. And then E, same thing. E is not above G, it's on G, so that's also an intersection point. So A is the only point. And then same thing here. So I'm going to flip this around because I'm asking questions about f of x, so I want the inequality to be similar to that. So where is f of x smaller than g of x? So I have here A. A is not smaller, not below, so it's not A. And then remember, B and E are both on G, so also not smaller. So in this case, there would be none. Okay, so for question number 32, there was a couple of different ways to do this. One of the ways we did this was to graph it. So let's take a look at the graphing method. So right here, these are all ordered pairs, just not written that way. They're written in a table form. So here they're telling us that x is 0, and then y is 0 here. So this ordered pair is 0, 0, And so I'm going to go ahead and graph that. And then over here, when x is 1, my y value is 2, so I have the ordered pair 1, 2. So I'm going to go over 1, up 2. And then over here, when x is 2, y is 4. So I'm going to graph the point 2, 4. And then finally 3, 5. And then to graph g of x, I'm going to switch to a different color here, and I'm going to do the same thing. So when x is 0, the y value is -1. So I'm going to graph the ordered pair 0, -1. And then on this one here, when x is 1, y is 3. So then I'm going to graph the ordered pair 1 and then comma 3. And then 2, 2. And then finally 3 and -2. So the pink graph is my g of x. Okay, so then for part A, it's asking us to shade intervals between the integers where the solution to where f of x equals g of x. And that's where our graphs intersect. So if I look to see where do the two graphs intersect, there's one point of intersection, which if I drop it down is between 0 and 1. So I would shade between 0 and 1. They also intersect right here. So there's another point of intersection, and when I drop that down, that's somewhere between 1 and 2. And then no other place do they intersect, so no more intervals are shaded. And then for part B, it's asking us to find where does g of x equal 0. And remember, when it says for g of x equals 0, that's when y is equal to 0, which means we're not going up or down any. So we're looking for an x-intercept. So when y is equal to 0, that's an x-intercept for g of x. So if I look, the graph of g, which is the pink one, crosses right here, so somewhere between 0 and 1. And one more intersection right here, somewhere between 2 and 3. And then finally for part C, it's asking for where does f of x equal 3. So I'm going to count up to 3, so y equal 3, 1, 2, 3, and then go across to f of x, which is right here, and then see where does it, and it lines up somewhere between 1 and 2. So 3 somewhere between 1 and 2. Okay? All right, and then let's take a look at 33. Okay, so for question number 33, I'm going to start with the top equation here. So I'm going to do that off to the side here. So I subtracted the 1 over to y because it's not grouped with the x. So then my start point is 0 because I'm not adding anything to x, and then positive 1. And then my stretch is 1. And it's a squared graph, so then that's going to be a quadratic or a parabola. So I have an inequality, so it's not equal, so I'm going to use an open dot and dashed lines when I graph this, right? So I'm going to go over 0, up 1, and then my stretch is 1, so up 1 to the right 1, and then reflect it to the other side, so up 1 and left 1. And then I'm going to use a dotted line to make my parabola. So this is saying that my graph y values right here need to be greater than my curve, right? So my y values need to be greater than my curve. So here's my curve. So to get to y values above that curve, that's going to be this section here. And I'm going to do the same thing again, but for the bottom equation. So I'm going to subtract the 1 over to the y. because if it belonged to the x, it would be grouped with it. So then my start point is going to be 0 because I'm not adding anything to the x, and then positive 1. And then my stretch is negative 1, right? So there's always an implied 1 there. So same thing, it does not have the equals underneath, so I know I'm going to use open dot and dotted lines when I graph this. So I'm going to go over 0, up 1, so that's the same start point here. But my stretch is negative 1, so in this instance I'm going to go down 1 and right 1, and then reflect to the other side because it's going to be a quadratic as well. And then dotted line when I connect. And so this is saying that my y values need to be below my curve. So y's need to be less than my curve. So that would be all of this section. And then I want to look to see where the shaded section is common, and there's no place common, right? There's nothing shaded up here and also down here. So there's no overlap, and so then that means there's going to be no solution. Okay, let's take a look at 34. So 34 is the same idea here. So I'm going to start with my top graph. So the 2 is grouped, so it's going to stay where it's at. So my start point is negative 2, 0, because I'm not adding anything to the y. And then my stretch is 1/3. And then I'm going to use closed dots because I can be equal. So when I graph these, I'm going to use closed dots and solid lines. So this is a linear absolute value, so my stretch is 1/3. So I can go up 1 over 3, or I could just go up 1/3 over 1, right? Either way. And then I'm going to reflect it to the other side, so up 1 and left 3. And then use solid lines to connect. And so now this is saying that I want to go towards the y values that are less than my absolute value. So where are the y values? Below my graph. And that would be all of this section here. So let's go ahead and do the bottom one here. So my start point will be 0, 0 because I'm not adding anything to x or to y. And then my stretch is negative 1. So it is equal, so I'm going to use closed dots for everything. So 0, 0, and then my stretch is negative 1, so down 1, right 1, and then reflect to the other side. So this is an absolute value, so then I'm just going to do connect those dots. And then now I want to shade everything to where y is greater than or equal to my absolute value. So where is y greater than or equal to my absolute value? So of the part that's already shaded, I don't want to go beyond that, right? So greater than or equal to this is everything up here, but I don't want to go beyond what's already shaded. So then it's just going to be this section here, because that will be my overlap. And so any of those points that are in this shaded region would be a solution to 34. Okay. And then let's go ahead and take a look at question number 35. So for question number 35, it says to solve the following quadratic equation. So the first thing I want to do is try to factor this. So I'm going to go ahead and list my factors for both of these, and see if it's possible to come up with two factors that will work for this equation. Okay, and so when I look at this, I know that I can multiply 3 times 2 for 6 and 1 times x for 1x. Okay, and so then for my factors, I'm going to use 3x and x, and I want 3 to multiply to the 2 and x to multiply to the 1. So I'm trying to get a negative 5, so I want my 6x to be negative, so that means 2 needs to be negative. And then add the 1. So that would be negative 6 plus 1, which is negative 5. And then I want to split my factors so I can solve because it's equal to 0. So I'm going to subtract 1 from both sides, and then divide by 3. And then over here I want to add 2 to both sides, so then x equals 2. So x equals 2 and negative 1/3. Okay? All right, and then let's take a look at question number 36. So here, if I tried to factor this, I have 2x and x and 1 and 1, but there's no way to get 6 when I do that, because that's just 2x and 1x. So that means if I can't do that, I need to do quadratic formula. So quadratic formula, so I know my a value is my coefficient of x squared, so that would be 2. And then b is my coefficient of x, which is negative 6. And then c is my constant, which is 1. So then for my quadratic formula, so if I don't know this formula, it's something I need to learn, right? So here is the formula for quadratic formula. And so I'm going to just state it, but if you don't know it, make sure you look that up, okay? All right, so we've got x equals, and then the opposite of b, so that would be positive 6, plus or minus. And then I want to square my value for b. So that would be negative 6 times negative 6 is a positive 36. And then minus 4 times a times c. And then all divided by 2 times a. And then when I simplify my radical, I want to do the part underneath the square root first. So I'm going to do this part right here. So 4 times 2 times 1 is 8. And then 2 times 2 is 4. And then go ahead and subtract. And then I know I can break down 28 to be 4 times 2, so I'm going to do that, try to squeeze that in here. So 28 is 4 times 7. So I'm not going to be able to take the square root of 7, but I know the square root of 4 is 2, and then 7 will stay where it's at. And then one last thing I can do is I can divide all of these by 2, so I'm going to go ahead and do that. Not the radical, because we're not trying to reduce that any further. So divide by 2, and then 2 divided by 2 is 1, so I could put the 1 or not. And then 4 divided by 2 is 2. Okay, and then that's it for this video here.